Welcome to Unit 5, Lesson 1, Growing and Shrinking. Let's calculate exponential change. Okay, so here is the basic of an exponential function, but in this unit, we're going to use y equals a times b. So we're going to replace this with y equals a times b to the x. I should put a different poster in here. Where a is your initial amount, your starting point, initial amount, and B is your growth rate. So highlight here. If B is bigger than 1, then you have growth or increase. If B is less than 1, it's bigger than 0 but less than 1, you have decay or depreciation. This is the difference between these functions. They both curve on one side, and they both have a horizontal asymptote on one side. So in the growth model, the one on the left, the horizontal asymptote is 0, and on the left side, and on the right side, it increases to infinity very quickly. So for the decay model, or the depreciation is to lose value or money. On the left side, you go to infinity very quickly, and on the right side, we decay to or depreciate to 0. Most standard exponential functions will come through the point 0, 1. Sometimes they move up and down due to changes, but for standards a times b to the x, it will come through the point 0 in x, 1 in y, so your start point will come through 1. Okay, let's look at our first thing. Before we start to solve the first problem, exponential functions are like geometric sequences. So let's remember our sequence. In an arithmetic sequence, we had some number plus or minus some other number times our variable, times our whatever we were doing. In a geometric sequence, we had our number a times our number b, and the variable was an exponent. So geometric sequences, back from unit 1, work like exponential functions. So now that we remember back to our sequences, let's work through the first problem. A bank account had a balance of $120 on January 1st. So this number represents our A, because remember, y equals a times b to the x power, where a and b are any real numbers. And describe a situation in which the account balance for every month forms these type of sequences. So if we were to deposit $20 a month into our account, we could write an arithmetic sequence like that, where you have two things plus. Now, a geometric sequence will be kind of different. We would start with 120, but let's say the account went up by a certain percentage, or by $5, or it doubled every month. So we're putting in $120 every month. So we would times 2, and then x would represent every month. X represents every month, but the difference here is arithmetic sequences add or subtract. Geometric sequences multiply or divide. And that is the key for exponential functions. We always put our b in parentheses so we know what our growth or decay is. Okay, let's look at problem 2. Ella needs a passport photo that meets certain requirements. One of the requirements is that the measurement from her chin to the top of her head is between 25 and 35 millimeters in the photo. So we have two numbers, and we had to ask ourselves, are these numbers important? 25 and 35. What are they? So if we have a passport photo, this distance here from your chin to your top of your head needs to be between 25 to 35 millimeters. Elena has a photo of herself in which that measurement is 150 millimeters. She has access to a photocopier that can reduce the height of the photo to 80% of its previous value each time it's copied. So the first thing we got to do is we have to write our equation. Let's see. 25 and 35 look like outputs, or what y equals. So I think that's an output. Her initial, she has this is initial, so I think this is our A, and B is a percentage. You cannot put percentages into an equation, so we have to change this into a number. So 80% literally means divide, and cent literally means 100. So if we take 80 and divide it by 100, so 80 over 100, which is 0.8 to the x power, I think we have an equation. 150 is our start. We want to finish at 25 and 35. There we go. Here's our equation. When we write exponentials, start with your equations. Okay, so now what we're going to do is take our equation and put it into the calculator. So you're going to hit the y equals button in the top left corner. So you're going to hit the y equals button, and you're going to see y1 through y6 or 7 or whatever, and type 150. You want to use parentheses. We always put b in parentheses. 0.8. Caret is over the division symbol, and then the xt theta n button is next to the green button on the left hand side. And then after you get your equation in, you're going to write second. You're going to push the second button, the blue button, and you're going to push the graph button, which is way in the top row on the right. And now, if x 150 is in millimeters, that's the size of the photo. 0.8 is our size shrinkage. That's how much the photo has to shrink. This must mean the times we photocopy it, or the times we shrink the photo. So once we figure out what the numbers stand for, we can do everything. So A, this equals x. Once you go to second graph, all you got to do is find your x's. If x equals 3, then y has to equal something. So when x equals 3, y equals 76.8. When x equals 6, y equals 39.3. So just go second graph, read down the table of values. Okay, so how many times would that image need to be scaled down? So we look for when y is less than 35. The first time y is less than 35, y is at 31.457. We're going to round that off to 0.5. And that's when x equals 7. So it takes 7 times to get a photograph and a copy, photocopying the picture to get it down to the size we need it to be. Okay, how many times would it take? Once you had the table of values up, you can solve all equations. So when y is less than 25, when's the first time that happens? Y is equal to 20.13 repeating when x equals 9. So after 9 times of photocopying, it gets smaller than what it needs to be. Okay, let's look at our next problem. On May 12th, a fast-growing species of algae is accidentally introduced into a pond. So May 12th, that is going to be day 0. Because before the contaminant is put into the pond, there's no of this type of algae. So now the area of the pond the algae covers doubles each day. So this is important. Doubles. This is a math word. Each day. So this tells us times 2 each day. This is our time period. If not controlled, the algae will cover the entire surface of the pond on May 24th. So now from May 12th to May 24th gives us 12 days. In 12 days, the pond will be entirely covered. So we need an equation We can't start at day 0. We're going to have to start at May 24th. So at May 24th, we get 100% coverage. And percent means to divide by 100. So this is 1. So that makes our A equal to 1. That's our start. We're going to go backwards. Why we had to go backwards? Because we can't go forward from 0. So y equals A times B to the x power. So our A is 1, our B. If it's times 2 going right, going left in the opposite direction, what's the opposite of times 2? Divide by 2. Or multiplying by 1/2. So our B is 1/2. So we're multiplying, we're not dividing these, we're always multiplying to the x. This is our exponential function. And now we could do everything from here. So in the calculator, again, y equals, you don't need to put this 1 in. You just put 1/2 to the x power. You don't even need the parentheses, but I'm just writing it for effect. Okay, so on which data is the pond halfway covered? So what's the x value? X equals what? When y equals 50%. Or 0.5, because if you divide 50 by 100, you get 0.5. And we see that x equals 1. Because we're going backwards from 100% coverage, May 24th is the day of 100% coverage. If we subtract 1, we're at May 23rd. Because from May 23rd, it doubles from 50% to 100%. Okay, on May 18th, Claire visits the park. Claire looks at how much of the pond is currently covered and thinks the caretaker is mistaken. All right, so on May 18th, which is 6 days before, 24 minus 18 is 6. So we're going to go 6 days before. So remember, our equation starts from May 24th and goes backwards because 1/2 is less than 1, and we have decay. So we're going to decay back to day 0. And so our x is 6 now. So when x equals 6, what does y equal? Y equals 0.0156. This number represents the surface of the pond that the algae is covering right now, that small amount. And finally, what fraction of the pond was covered by the initially on May 12th? So 0% of the pond was covered initially. All right, so let's put it in the calculator. So when x equals 12, y equals, what's the number at y when y equals? The number we get is 2.4 e to the minus 4 in the calculator. So e means times 10 to the minus 4th exponent. E stands for exponent. So 2.4. What this tells us in scientific notation is move the decimal point 4 places to the left. 1, 2, 3, 4. So you get 0.00024. This is how much of the surface of the pond was covered when the stuff was spilled in the pond.